Today we discuss confidence interval method of z-test for one population mean test. We use confidence interval method to calculate a range of possible values for population mean. Now to calculate the confidence interval values for z-test, we have to use the following confidence interval formula. So to use this formula, we have to remember one critical fact over here, that is we all time use total critical value for z to calculate the interval. So আমাদের hypothesis one tail হোক or total হোক, it doesn't matter. To calculate confidence interval values for z test, we have to use the total critical value for z to calculate our interval. So if we use this formula, now we find the following two interval values from this formula. First if we add this component with x bar, that means sample mean. If we add this component to the sample mean, we find mu1 equal x bar plus z alpha by 2 multiplied by sigma root over n. If we minus this component from the sample mean, we find another interval values, that is called mu2 equal x bar minus z alpha by 2 multiplied by sigma root over n. Sigma divided by root over n. So these are the two different interval values. One interval value is referred by mu1 and another interval value is referred by mu2. So these are the two interval values that we can easily derive from this formula by adding and subtracting this component from the sample mean. And we have to remember that in case of interval values, we have to use the total critical value all time. Whether hypothesis one tail or two tail, it doesn't matter. We all time use total critical value to calculate our interval values. So once we know how to calculate interval values, now we can use our confidence interval testing rules to decide whether we should reject null hypothesis or alternative hypothesis. So first of all, we say that if one of the interval value is more than the population mean, and another interval value is less than the population mean, so this is our population mean. If one is more, less, another is more, in that case we fail to reject null hypothesis. So as we read over here, if one value is smaller and another value is greater than the population mean, in that case we must fail to reject null hypothesis. So we show this result graphically as follows. So in the graph we see that this is our population mean, and our two interval values is, one of the interval value is mu1 and another interval value is mu2. And as we look over here, this interval contains our population mean, because our population mean is at the center of this interval, and since our population mean is contained in this interval, we simply fail to reject null hypothesis. Okay, now in the second case, it could be that the range of two interval values are more than the population mean. If two interval values are more than the population mean, and these are population mean, as we see, the two interval values are more than the population mean, in that case we reject null hypothesis. So as we read over here, if both values are greater than the population mean, we reject null hypothesis. This is the second case. Now we also show this result by graphically as follows. From the graph we see that these are population mean, and our two interval values are mu1 and mu2 are more than the population mean, and this is our intervals, and in this interval we do not find our population mean, and because population mean is situated population mean is located over here, and our interval values are located over here, and in this interval we do not find our population mean. So for this reason we must reject the null hypothesis. In the third case, it could be that both interval values are less than the population mean. So this case, both interval values are less than the population mean, the mu. Okay, in that case we also reject null hypothesis, because both values are less than the population mean. If we show this result graphically, we see that this is our population mean, and both values are this, and this interval do not contain our population mean, because our population mean is located over here, and since our interval do not contain population mean, we just reject null hypothesis. So far we have got our confidence interval testing rules. One of the rule is, if both values are less than the population mean, we reject null hypothesis. If both values are more than the population mean, we reject null hypothesis. If one value is less than the population mean, another value is more than the population mean, we fail to reject null hypothesis. And we have come to know what is the formula for calculating our confidence interval, and from this formula we find these two confidence interval values. One value is referred by mu1, another value is referred by mu2, and this is the formula. And we repeat once again, to calculate interval we have to use all time the total critical value of z. Whether hypothesis one tail or two tail, it doesn't matter. All time we use the total critical value of z to calculate our interval values. So far in this video we have seen how to calculate interval and what are the different testing rules for confidence interval method, and that's all from this video.